Welcome to another session of probability theory and the concept, which we are going to introduce the scales of measurement of data. This point here now is very crucial because once you understood this, you will understand the nature of all random variables and how you can figure them out in computation of your probability, and you have less confusion about a discrete and continuous random variable. To start with, we say scales of measurement refers to ways in which variables or numbers are defined and categorized. So each scale of measurement has a certain properties which in turn determines the appropriateness of using a certain statistical analysis. This will be like our guide during the statistical analysis. For any statistical analysis, we need to understand the probability distribution or the nature of scales of measurement. And these scales of measurements famously are categorized into 4. Although you may say 5 if you include binary, but binary is part of the nominal. So if you say 4, it means binary is inclusive with nominal. And we say these 4 are nominal scale. You can say about the ordinal scale, interval scale, as well as the ratio scale. The mathematical operation are important criteria on naming and identifying a scale of measurements. And when we are speaking about the mathematical operation here, we are referring to 5 operations: the addition, subtraction, multiplication, division, and inequalities. Those are the 5 key components which you are going to use when you are going to define or explain about the scales of measurements. To start with, the nominal scale. The nominal scale of measurements, we say these are numbers assigned to a certain categorical variables, and these serve as the tags or labels only for the purpose of categorization. Example: a variable like gender has most of the time the response we recorded from the gender is only 2. There are only 2, male and female. For statistical analysis, since male and female, these are text, they are under the class of qualitative. In order to work with them in quantitative analysis, you need to code them. You need to assign the numbers which will be used instead of those terminologies. Maybe 1 for male, 2 for female, and vice versa. So if you have such kind of scenario, we say now what you have is a nominal scale. Something like marital status. If you say 1 should represent a single, 2 should represent married, 3 should represent widowed, and so on and so forth. So instead of having those terminology as single, married, or whatever, you just have 1, 2, 3. So someone may understand this 1 is for single, 2 is for married, and so on and so forth. And you may see those are not measured values. Those are assigned numbers and their affinity. That's why they are under the class of categorical variable. So under nominal scale, we said before, these mathematical operations are the key component in identifying these scales of measurements. How? I can explain a bit here. I will use the example of 1 and 2. I will just explain because I didn't write down the full skeleton about how it works. So when we say 1 and 2, under mathematical perspective, if I say 1 is male, and if I say 2 is female, under mathematical perspective, we say 1 plus 1 is 2. That is correct mathematically. But here, if you try that, it is wrong. Because simply when you say 1 plus 1 is 2, remember the meaning behind 1 is male. So simply you are telling us that male plus male is equal to female. Is it okay? You may find that is awkward. So that's why we say here additive mathematical operation cannot be applicable. Again, we know under the mathematical perspective, 2 minus 1 is 1. Here, simply if you say that, it means female minus male is equal to male. Again, it is awkward. That's why subtraction also, it cannot be applicable here. And again, we say 2 divided by 1 is 2. So it means female divided by male is equal to female. Again, we don't work like that. So it means here we saw that the additive, the multiplicative, the subtraction cannot be applicable. For the inequality, again, we know 2 is greater than 1. Simply we are telling here that female is greater than male. Anybody with a sense must ask in which perspective. If we just leave it like that, no, it is not true. That cannot happen. So you see all those 5 mathematical operations, it is not possible to apply them here under nominal response. So first of all, nominal is categorical. You must have a limited responses, and those responses are coded, and we saw no any mathematical operation can be applicable. If such is the scenario, we have the 3 famous measures of central tendency. We have median, we have mode, we have mean. From the mean perspective, you need to add all response, then divide by the number in order to obtain mean. And we saw we cannot add. So if you have nominal data, it is impossible for you to compute mean. So mean will never ever be the appropriate statistic here. Again, for median, you need to rank your responses from largest to smallest, or vice versa, ascending or descending. And we saw that inequality cannot be applicable here. So again, median is not an appropriate statistic here. But we know mode is just a matter of counting the highest frequency, and it is impossible here. Since it is possible, it means only mode measure of central tendency can be computed. So do not expect to obtain median or mean under the nominal scale of measurement. I think I made myself clear at this point. Now I can move to another scale, which is the ordinal scale. Ordinal scale is closely related or resemble the nominal scale. First of all, why they are closely related? Because again, in the ordinal scale, you have the limited response, and they are text. But it is possible to rank the responses. How? I can speak something like in level of education. In level of education, if you have this question, under our country, you can code it like this: no education, primary education, secondary education, college education, and university education. Here, you will end up have 5 responses, and these are limited responses. Whoever you are going to ask about this question, he or she must fall under those 5 or 6 categories. If that is the scenario, but we know for sure that primary education is better than no education. Secondary education is better than primary and no education. Likewise, the college is better than the preceding one, and the university is the highest. Again, we can code this: 0 for no education, 1 for secondary education, 1 for primary education, 2 for secondary education, 3 for college, and the highest number for university. So here we can clearly see that 2 is greater than 1. Secondary is greater than primary. Primary is greater than no education. University is greater than college. Out of all those 5 mathematical operations, inequality here can be applicable. But again, can you add primary and secondary? Impossible. If it is impossible to add, also it is impossible to subtract. Can you multiply university and college? Again, it is impossible. It is awkward. But you can rank. Something like this, another example, something like a GPA class. We know first class is greater than upper secondary. Upper secondary is greater than lower secondary. Lower secondary is greater than pass. So again, you can rank those responses, which means inequality is applicable. And this is the only distinction between nominal variable or nominal scale and the ordinal scale. You may find that if you use nominal scale to make discrepancies, even some of the people may end up complaining, like the issue of racism. A variable of race, someone being black, white, and any other race, people end up complaining because it is nominal. There is no this one greater than this one. There is no such a thing. That's why if you use a nominal variable as a criteria of making a discrimination, people may end up complaining. But if you use the ordinal variable, you will never hear the complaining. Something like those with the first class, those with the upper secondary will never complain about those with first class because they know they are above them. Those with the lower secondary, they know they are above them. So this is the scenario of ordinal scale. So from this one, you see that it is impossible to rank, but still we cannot say how many times first class is better than upper secondary. How many upper secondary, if you add them, we may end up receiving a first class. So such things are impossible. So still here you can count. If you can count the measure of central tendency mode, it can also be applicable. But again, since you can rank, and you know the rank is the most crucial property for median, it means here now, for this kind of scales of measurement, you can compute median. As long as you can rank, yes, because what median does, take the middle value after arrange them from the descending to ascending or vice versa. And here in the ordinal scale, it is possible. So for ordinal scale, you can compute median, but still you cannot compute mean, because still it is awkward to add the lower secondary and the upper secondary. Cannot tell that first class plus first class is equal to what, or upper secondary plus upper secondary is equal to what. Like this, if I say 1 is lower secondary, 2 is upper, is 1 is pass, 2 is lower secondary, 3 is upper secondary, and 4 is first class. What it means here, 2, which is lower secondary, under mathematical perspective, 2 plus 2 is equal to 4. If you do the addition, simply you can tell us that lower secondary plus lower secondary is equal to first class. And that is not true. Or simply you are telling us pass times 4 is equal to first class. So again, you cannot multiply, you cannot add. You will end up having mod, and you will end up having median under the ordinal scale. So again here, I think I've made myself clear for the issue of ordinal scale. Remember, any variable which is categorical, first of all, look at the responses. Look at your responses. Can you rank those responses? Then that is ordinal. If you cannot rank it, that is nominal. Something again I forgot to clarify here. For ordinal variable, those numbers must be named, must be assigned depending on the rank of the response. We know under mathematical perspective for this kind of categorical, for this kind of scale of measurement, inequality is applicable. We know first class is greater than pass. We do not expect you to assign 1 for first class and 4 for the pass. While we know under the mathematical perspective, 4 is greater than 1. So this is a confusion. Always prefer to name the higher ranked response, use the higher number. The lower ranked response, use the lower number. It is preferred like that. That one will have less confusion during the computation of median and wherever. The third one now. We are done with the categorical class. Categorical class can have nominal or ordinal. Now we are turning to the measured class. The first two, nominal and the categorical, can be the foundation of building our discrete random variable, because we can count. The next two, are going to be the foundation of a continuous random variable because these two are measured. These two are measured. And here now we have the interval scale as well as the ratio scale. About the interval scale, as we saw before, the similarity between the nominal and the ordinal, both of them, they have limited response. We call them categories. But the only discrepancy for ordinal, you can rank the response. Here again, there is a demarcation, something which will tell the difference between ratio and the ordinal. And what is that? There is what we call true zero. I think I should explain this concept first. What is true zero? We know zero under normal circumstances mean nothing. It means nothing. When zero indicates nothing, it is called true zero. But not in all circumstances, zero will mean nothing. There are some of the scenario, zero is a value greater than a sum of the values. In such kind of a scenario, we say that is a false zero. It is not a true zero because it does not indicate nothing. Zero indicates absence of measurement. If someone tells you the height is zero, it means no height. The edge is zero, it means no edge. So the true zero, zero means absence of measurements. But now here for the interval scale, the definition. An interval scale is a scale of measurement whereby the presence of zero does not indicate the absence of measurement. There is a number beyond zero. In short, if you see zero under interval scale, that is a false zero. And the example for this, I will start with the first one, which is most famous, the temperature. If someone tells you the temperature is zero, it does not mean there is no temperature. It does not mean there is no temperature, since temperature can fall below zero. So under such kind of scenario, when you see temperature is zero, it means that zero is a false zero. Under this now, just like ordinal improved nominal, from no use of any mathematical operation to inequality, interval scale also improve the ordinal. Inequality will be there. Because we know if the temperature is 20 degrees centigrade and another temperature is 10 degrees centigrade, we know obviously 20 is greater than 10. And if that is the case, inequality is applicable. We know obviously 10 is less than 20 since there is inequality. But what else? You can add these two. 10 degrees centigrade plus 20 degrees centigrade, we know it is obvious, this is 30. So additive is allowed. Subtraction also, 20 minus 10. You can have 10. So subtraction is allowed. But how about multiplication? You may be tempted to say that 20 degrees centigrade is twice as 10 degrees centigrade. Yeah. If that is the case, now answer this. Minus 10 degrees centigrade is how much times you can have 10 degrees centigrade. You may see that it is impossible. 10 degrees centigrade is how much times the 0 degrees centigrade. You will see that it is impossible. If you cannot multiply here under interval, also cannot subtract. You cannot divide the two. Because what if I say take a 5 degrees centigrade divided by 0 degrees centigrade? Infinity? That is not possible. So here now we see, rather than inequality, also you can add and you can subtract. And if you can do that, now the mean will open up. Because we know the arithmetic mean can be computed by summing up all of the observation divided by the count number, total count number. And since we can sum 20 and 30, it is possible to obtain the arithmetic mean. Remember, why I'm pointing out the arithmetic mean? It is not possible for you to compute the geometric mean, because the geometric mean will need you to multiply, to product together the item values. And we see that the product, the multiplication here under interval scale, it is not possible. So you may end up computing the mean, the median. We may end up computing the mode, the median, and the arithmetic mean, but not the geometric mean. So under interval scales, we cannot compute the geometric mean. Another example of interval scale is all the deviations. All the deviations. Remember, deviation can fall below 0. If you are taking a value minus mean, then it may be possible mean is greater than that value. So it may be 0. The moment you are dealing with deviations, you can compute the mean deviation, but you cannot compute the geometric mean of deviation. Why? Because it is no longer a ratio, but rather an interval scale, as I pointed out here. The last one is the ratio scale. The only difference here is the ratio scale have true 0. The interval scale, it has false 0. Just like the ordinal variable has rank compared to the response from nominal. Here, the ratio scale has a true 0 compared to the interval scale. Why? Because the presence of 0 here indicates absence of measurement. So something like height. If height is 0, no height. If weight is 0, no weight. If distance is 0, no distance. If velocity is 0, no velocity. And so on and so forth. And actually, most of the measured variables, 99.99%, they are in ratio scales. Because we see the limited examples here from the interval are only temperature and deviation. If you know another example, you may notify me, because up to this moment, I know only those two. So here, since there is a true 0, you can say 20 centimeters is twice as much as 10 centimeters, because there is no value beyond 0. You can multiply, you can add, you can subtract, you can tell the inequality 20 is greater than 10, something like that, and so on and so forth. And if that is the case, it means now this kind of scale possesses the inequality property, the additive property, the subtraction property, the multiplication property, as well as the division. So we say, as I said before, these 5 are going to be they are going to be a criteria for marking the difference between 2. From nominal, no any mathematical operation. Ordinal, only inequality mathematical operation. Interval, there is under interval scale, inequality is applicable, additive as well as subtraction, while under ratio scale, all those 5 will be applicable. And you may find here also it is possible for you to compute the geometric mean, since those observations, those values can be multiplied together, and you don't have a problem with that. So here you will find a little bit summary about what I have spoken about. You can first classify scales of measurement into 2 groups. The first one is categorical data. Is a variable with a fixed number of responses, and this is the terminology which mark the categorical. So in nominal scale, we say category cannot be ranked, such as male and female. In the ordinal scale, the scales can be ranked, such as agree, neutral, disagree, in linked variables. Measured data. In any data which a unit of measurement is any data with a unit of measurement, such as centimeter, kilogram, and wherever. Interval data, measured data, is a measured data with a false 0, such as temperature, while ratio data is a data with a true 0, such as height, weight, and so on and so forth. So all data which are in ratio or interval scale can be converted to categorical, such as when you hear GPA class, original GPA is ratio. Original GPA is ratio. But you can convert it back to categorical by putting class 4 point something up to 5 maybe. You put it as a certain limited response. Age group is categorical, but age is continuous. Income range is categorical, but income itself is continuous. Remember, since under the ratio or interval there is inequality property, when you convert this variable to categorical, it must be ordinal scale and not nominal, because it will inherit the ranking property from interval and ratio. That's why something like GPA class is ordinal and not nominal. That's why something like age group is ordinal and not nominal. That's why something like income range is ordinal and not nominal. Why? Because it will inherit the ranking property available in ratio or interval. That is what I can say in a nutshell about the scales of measurement. Having understood that, now we're making ourselves ready to define the probability distribution, because the random variable will fall out of these 4 classes of scales of measurements. Among those 4, no other way around.